Okay guys, so today we're looking at something that people generally find kind of complicated. It's called a recursive rule. So we've been working so far with just explicit rules. Explicit rules give a sub n as a function of the term's position number n in the sequence. That's a mouthful there. So we have like a sub n equals, 3 plus n, for example. So that means then that our first term would just be 3 plus 1. Our second term would be 3 plus 2, etc. So they can be written like that. It's easy to do the problem because it's not based off of anything. But recursive rules, we have to be given the beginning term of a sequence and a recursive equation that tells how a sub n is related to one or more of the preceding terms. Note that on the ACTs and SATs, a lot of times this will be written as a sub n plus 1 equals a sub n plus 4. And they would have to tell you what a sub 1 is. For example, they might say a sub 1 is 2. And then if I want to find a sub 2 would be 1 plus 1, so n would be actually 1. So I would do a sub 1, which is 2, plus 4, which is 6. And then a sub 3, meaning a sub 3 means that n would have to be 2, so I do a sub 2 plus 4, so I take that number plus 4. A sub 4, if this is 4, then n is really 3, so it's a sub 3, which is 10 plus 4, and you can obviously see how easy the pattern goes once you kind of get started. You're just adding 4 every time. So recursive they're not hard to figure out, they're just hard to come up with sometimes, as you'll see in a little bit. So in this one, if a sub 1 is 10, so we already know the first term, so now it's saying the second term, the next term, is going to be my second term would be a sub 2, which means n is really 1, so it's 2 times a sub 1. Well, a sub 1 was 10, so 2 times 10 is 20. And this just is going to mean the next term is 2 times the one before it. So there would be our first 5 terms. Now it wants us to write the explicit formula. So for the explicit formula, we don't have to state a sub 1. We just would say a sub n equals, and then I can see that we're multiplying by 2 every time. I know the formula for a geometric sequence goes a sub 1 times r to the n minus 1. So in this case, a sub 1 was 10 times my r is 2 to the n minus 1. Now, before I say that's my answer, I might want to check it. Like my fourth term, n would be 4. 4 minus 1 is 3. 2 to the third is 8 times 10, 80. Great, that's what we wanted. All right. Recursive equations for arithmetic and geometric sequences. It's kind of nice. These have definite formulas. A sub n is going to be a sub n minus 1 plus d. For a geometric sequence, a sub n is going to be r times a sub n minus 1. See, if I'm given a sub n minus 1 just means the term right before it. When I'm given a sub n plus 1, a sub n would be the term right before it. Okay, so it's always based on the previous term. So down here it says find the first 6 terms of the sequence. Find the recursive geometric, or for a recursive geometric, write the other way it could be written. So we're supposed to write the first 6 terms. They tell us a sub 1 is negative 3, so I'm going to write that. This means the next term is going to be the one before it plus 4. So I'm just going to add 4. The next term is going to be the one before it plus 4, plus 4, plus 4, plus 4. So there would be the first 6 terms. These two mean the same thing. See, in this case, a sub 2, n would be 1. So I take a sub 1 and I add 4 to it. This one is saying a sub 1 is negative 3. A sub 2 is equal to, n is 2. 2 minus 1 is 1. A sub 1 was negative 3 plus 4. So they mean exactly the same thing. Okay, for the recursive, I have negative 3 is my first one. It says my next term is going to be times 4. Times 4. Times, let me grab a calculator. We're just going to keep multiplying by 4. No big deal. probably don't even really need to write these, but just multiplying by 4 every time. We have negative 192. Write another one. Negative 768. And then our last one is negative 3072. Now, we also, on the geometrics, it says to write the other way it could be written, meaning explicitly. See, this is recursively because they tell us a sub 1. Explicitly means that I don't have to give a sub 1. So I would just say a sub n equals, I use my formula, a sub 1 times r to the n minus 1. That's our rule for geometric. So it's going to go a sub n equals, a sub 1 is negative 3 times r was 4 to the n minus 1. And it's always a good idea to check it. Let's check like this third term. N is 3 in the third term. 3 minus 1 is 2. 4 squared is 16. 16 times negative 3 is going to be negative 48. So that all checks out just fine. Now we could go back and write this one explicitly as well. We might as well do that, even though it doesn't say we have to do that. Let's write this one explicitly using our formula. So you got to think back, and if you don't know it, you can always look it up. What's our formula when we have an arithmetic sequence, or how do we find those terms? Right here it is. This is something you're going to need to have memorized for the quiz. A sub n equals a sub 1 plus n minus 1 times d. So if I wanted to write this one explicitly, it would be a sub n equals, we have to do that formula that we just said. Look back at it. That's geometric. It was a sub 1 plus n minus 1 times d. So we look at this, and we've got a sub n equals a sub 1 plus n minus 1. The d value is 4. Simplifying that, negative 3 plus 4n minus 4. So a sub n equals 4n minus 7. That is the explicit way to write out that recursive formula. Check it out for a term. Fourth term. 4 times 4 is 16, minus 7 is 9. So it works. Okay? So explicit versus recursive. Okay. In exercises 1 and 2, write the first 6 terms of the sequence. You should pause the video and try these on your own. These two, well, this one especially is easy. Might want to turn it back on for that one if you can't get it. So pause it, try this. A sub 1 is 2. I'm just going to keep adding 5. And that's it. Those are the first 6 terms. This one looks a little different, but it's really not that bad. It's saying f of 0 is 1. And so if I want to find f of 1, n is 1, so we're going to do 2 times f of 1 minus 1. Well, 2 times f of 0 was 1, so 2 times, see what I'm doing here? F of 0 is 1, so 2 times 1 is 2. So I'm going to have 2. And then my next one is going to be just multiplying by 2 is what this is saying. See, what this is really saying is the term is going to be equal to 2 times the one before it. That's all it's saying. So really, we should start with the 1. That was the first one they gave us. Keep multiplying by 2. And there you go. Not difficult. All right. Now we are given a pattern. We're supposed to come up with the recursive sequence, rule for the sequence. The first 2 are pretty easy. If you want, you can pause the video, try these on your own. The second 2, 5 and 6, very difficult. All right, let's look at number 3. So on number 3, if I'm going to write recursively, I say a sub 1, I have to tell what that's equal to. Then a sub n, I'm looking at this pattern. I'm adding 3 every time, so this is arithmetic. And back on that other side, we had that rule for the recursive arithmetic, and it's just going to be a sub n equals a sub n minus 1 plus d. Look back through your notes to find formulas. So this is going to go a sub n minus 1 plus d is going to be 3. That's how much we're adding on every time. And I should check it out, see if it works. The third term, would be equal to a sub 2, which is here, plus 3. Works. All right, the next one, I can see that I'm not adding or subtracting the same amount, so this might be geometric. I'm going to test it out. I'm going to find r. r is 20 over 50, 8 over 20. I want to see if those are the same. 20 over 50 is 2/5. 8 over 20 is 2/5. Yep, so this is geometric. Look back at how your recursive geometric goes if you need to. Recursive geometric is going to be a sub n equals r times a to the n, a sub n minus 1. So it's going to be a sub n equals a sub 1 times, a sub n equals r times a sub n minus 1. So in this case then, a sub n is going to be equal to, this ratio every time is 2/5 times a sub n minus 1. And there's one thing that we need to make sure that we understand, that a sub 1 is part of the formula, is part of this recursive rule. You need to write this whole thing here. And for this one, I have to state what a sub 1 is. Let me just rewrite it. A sub 1, I have to tell what it is, and then a sub n is equal to 2/5 a sub n minus 1. Every recursive, you've got to tell at least a sub 1, sometimes even a sub 1 and a sub 2. All right, the tough ones now. I look at this. I'm adding 1, subtracting 3, subtracting 4, subtracting 1. That's not arithmetic. I try geometric. Multiply, 4 divided by 3 is 4/3, that's 1/4, -3. It's not arithmetic or geometric. When this happens, I've just got to try to find a pattern. This pattern is pretty tricky. But do you notice how if I do 4 minus 3, I get 1? If I do 1 minus 4, I get -3. If I do -3 minus 1, I get -4. You see what I'm doing? 4 minus 3 is 1. 1 minus 4 is -3. -3 minus 1 is -4. -4 minus -3, what's -4 minus -3? That's going to take me to -1, would be the next term. This is complicated to notice. It's something you've just got to really keep looking. Is there any kind of pattern I can see? Well, the pattern we see is that we have to do this term minus this one, this term minus this one. Okay, and these types of things do show up on recursives. So a sub 1 in this case I have to say is 3. I would also have to be told or tell someone what's a sub 2, because they have to know the first two terms to get the pattern going. Then I would have to say a sub n, like that third term, is going to be equal to the one right before it. What do we call the one right before it? A sub n minus 1, right? Minus, and then I have to do the one that's 2 before it. So it would have to be a sub n minus 2. That's what's going on. So let me just check this out. So my fifth term, just kind of checking, would be a sub 5, should be 5 minus 1 is a sub 4 minus 5 minus 2 is 3. So does that work? Would my fifth term be equal to this minus that? That works, doesn't it? So therefore, this would be the recursive formula. You might be thinking, I would never think of that. And yeah, you're right. At first, you don't think of those kind of things, but the more of these you practice, then the more likely you are to see that pattern and be able to write it. Let's look at the next one. I check to see if it's arithmetic. I am adding 2, I'm adding 3, I'm adding 4, I'm adding 5. That's not arithmetic. My r here would be 1/3, here it would be -2, here it would be 3. It's not geometric. So what do? Well, I've got to try to figure out what's going on here. You might want to pause the video and see if you can come up with it. It's going to be maybe something like this. But here's the way it goes. I know I have to at least tell what the first term is. I might even have to tell what the second term is. I don't know. Let's see. So we said that to go from here to here, we add 2. To go from here to here, we add 3. To go from here to here, we add 4. Here to here, add 5. So let's see. How could we write that then? A sub n is equal to the previous term plus, here I'm adding 2 on my second term. To get my third term, I'm adding 3. To get my fourth term, I'm adding 4. To get my fifth term, I'm adding 5. Well, what are we just adding on? N. Okay? So here's this one. And this is one that I don't think many people recognize at first, but what we're doing is, like, let's say I'm trying to find the fifth term. Just checking it. A sub 5 should be equal to a sub 5 minus 1 plus 5. So a sub 5 should be equal to a sub 4 plus 5. What's a sub 4? 6 plus 5. Yep, it works, doesn't it? Okay? So that's it. So you're going to have some of these on your Big Ideas assignment, and some will be real easy. The arithmetic and geometric, no problem, right? These, you got to think outside of the box. And the only way you can do it is to practice it and persevere. These you can't give up on, because these are tough. Like, you look at it and you're like, I just have no idea. But then if you try things and just look at it, like this adding on of n, it's not something we'd really think about, but it does show up. Or subtracting these, you know, wouldn't think of it immediately, but, you know, it works. So you got to kind of do a guess and check type of thing, and don't give up on it. All right, that's it for that.